Hello everyone, today we're going over the LeetCode hard question, maximal rectangle. The question is, given a 2D matrix filled with zeros and ones, find the largest rectangle containing only ones and returning its area. So in the example below, the largest rectangle is the blue area here and the total area is 6. Pause the video here if you like to think independently first. To solve this problem, it's very useful if we look at another similar LeetCode problem, the largest rectangle in histogram. The question is, given an array of integer heights representing histogram's bar height, where the width of each bar is 1, return the area of largest rectangle in the histogram. In the example below, the largest rectangle is the bar height of 5 spanning 2 bars, so 5 times 2 equals 10. Let's stare at the diagrams a bit and try to focus on breaking the problem into smaller parts. Can we calculate the largest rectangle for each element? For example, if we look at the first bar here, the largest rectangle it can form is just itself. The second bar, it has the width of the whole histogram. And the third bar has a width of 2. So on and so forth. If we can calculate the largest rectangle for each element, we can compare and find out the maximal rectangle. The idea is that for each element, the rectangle it can form is its height multiplied by how long it's been the minimum height for. So for example, let's look at the element 2 here. Its starting position is at 1 because 1 is the first number that's smaller than 2. And the ending position is the end of the array. So for this element, the area is 2 times 4, which is equal to 8. And it's this area on the histogram. Now, of course, we can use a brute force approach to calculate the start and end index for each element. But we can do better than that by using a monotonic stack. We'll keep track of the starting indices by going through each element from left to right. And we'll add them to a stack. The stack will only be popped under certain condition, and that is when the current element is smaller than the top of the stack. Here's the Python code for the solution. The key part is when the top of the stack is greater than the current height. We're ready to pop the element and calculate the area of the rectangle. This area is the height, which is the element's height, times the width, which is the current index minus the starting index. And again, the starting index is the index of the leftmost element that's smaller than the current element. So we'll also update that in the stack. Let's go through the code with the given example. We'll start with the stack with starting index of 0 and the element 2. There's nothing to be done here, so we move on to the next element. Since 1 is smaller than 2, we're ready to pop 2 out and calculate its area. The area is 2 and we update the max area accordingly. Then we add 1 to the stack. Let's move on to the number 5. 5 is bigger than 1, so we simply just add it to the stack. And next up, the number 6. 6 is also bigger than 5, so we also add it back to the stack. Next up, the number 2. 2 is smaller than 6, which means we can pop 6 out now. Let's calculate the area for the number 6. The height is 6 and the width is 4 minus 3 equals 1, so the area is 6. And we update the max area. Since 2 is smaller than 5, we should keep popping 5. For the number 5, the area is 5 times 4 minus 2 equals to 10. So the max area is now 10. And since 1 is smaller than 2, we stop the popping here and add 2 on the stack. Now you can see that the stack is always increasing in value, hence the naming monotonic stack. We can continue the processing to add the number 3 and do a final pass on the stack to pop every element out. So popping 3 out, calculate the area. Then pop 2 out, calculate its area, and finally pop 1 out. Since we're only doing one pass of the array, the time complexity is O(n), and the space complexity is also O(n). Now back to the maximal rectangle problem. What if we treat each row as the base of the histogram and calculate the max area for each histogram? The only thing we need to pre-process here is the histogram height for each row, and that's relatively easy. We'll start with the first row. The histogram heights are the values themselves. As we move to the next row, if we see the value 1, we increment the current bar height. However, if we see a 0, we reset the bar height to 0. And by doing this, we'll get the histogram representation for each row. Here's the pseudocode. Again, we first update the heights array, then using the aforementioned method, we'll calculate the histogram max area. Note that we'll append the value of -1 to the heights array, so we can pop out the remainder of the stack as we reach the end of the array. The final time complexity is the number of rows times columns, or n times m, and the space complexity is O number of columns. That's all for today. Thank you for watching. Let me know if you have any suggestions in the comments and which questions you want to see next.